Yeah, guess we should just get started. So everyone, this is our C lecture. Oh, also, welcome everyone from YouTube and from the blog sites. Hello, my name is Numberman, and today we will be talking about C, the programming language. C, just C. It's a little weird sometimes. Just say C. Anyway, nope, no plus pluses, no sharps today. It's just C. The TDS doesn't work even with bits. It does with bits. It does with bits. Shouldn't have said that. I should not have said that. Anyways, yes, one of the most influential programming languages in history. Well, you've just heard me say that. C++, C Sharp, Java is based on C. And really, not just that, right? Python, for example, PHP, I believe as well, are built upon C or built with C. So, of course, it's not purely C, but like the interpreter is programmed with C. So it's a very influential language. I think we'll get to that in like a second, but let's just talk about what this lecture is really about and whom it is for. You know, this is really just to expand your programming arsenal that you might already have, right? So what this is definitely not is really an introduction for beginners. It's something that I have like a little pet peeve with. You know, you have like a new language that you want to learn, like C or something else, and then you look up, well, C for like beginners. Because, well, you are a C beginner, but then you get these like 4-hour lectures that are filled with, okay, what is an integer? What is a control flow? All right, well, I know all of that already. I already have some experience with some other programming languages. That is basically what this lecture is for. If you are already a programmer, but you only know Java, maybe you know C++, C Sharp, maybe you know Python, doesn't matter. If you have done any programming language, you'll know what a type is. You'll know what control flow is. You know, an if statement, an else statement, a while, for loop. You know all of that stuff already. So I'm not going to talk about that in this lecture. This is really just to expand what you already have into the C programming language. So that's basically what we're going to do. So we'll talk a little bit about the background, about C, like what is C, why would you choose C? Then we'll talk a little bit about how you can write C, like what should you use, like what IDEs are helpful for writing in C, and how to compile it, of course. And we'll take a look at the hello world, and just the standard hello world function. So, you know, we can just kind of get into it that way. You know, it's the normal way of doing this. Oh, here we go. So after the hello world, where we just kind of, you know, we get into it, we talk about some other basic stuff. We'll talk a little bit about pointers, some arrays, some strings, and really just some stuff that is a bit different in C than in some other languages. You know, it's just a bit different because 5 plus 5 is still 10 in C, so that's not too interesting. But these 3 things you'll find are a bit weird. Well, in that case, let's go to the background. So, C was made by, and I have written this down because I would forget, Dennis Ritchie at Bell Labs in 1972. So yes, it's already a very old language. It's basically 50 years old now. I think in like a few months, it's 50 years old now. So that's pretty poggy. I don't know that many other languages that have made it this long. Like Fortran or something, sure, it's a bit older, but I don't see anyone program in Fortran anymore. You know, I've never actually seen it in my life. Never seen anyone program in Fortran in my life. So yeah, C is in respect to that very popular still. And of course, it's not the most popular language right now, but its children, let's say, its legacy lives on in C++ and C Sharp and Java and all of that. And of course, it's still being actively worked with because things like Windows and, like I just said, Python, for example, are built upon C. So there are definitely still some very important programs still written in C to this day. Which brings us to why, really? Well, it's a native language, which means that anything that you write in C will get compiled directly into machine code instead of into some interpretable code like with Python, or into some intermediate language or some bytecode like with C Sharp or Java. those languages still need some other bit of software to really function, because on its own, this code, this bytecode or this interpretable code, it can't really do anything. Except for, well, being read by an interpreter or by some virtual machine or, well, virtual machine. For example, the Java runtime environment, or for the common runtime, the common language runtime. I forgot a letter there. Or C#. Those bits of software have to basically read the other code in order to execute whatever you've written on the machine. But for C, it gets compiled directly into machine code, which means that your computer can just run it natively. That is what's called native. That is pretty nice, because it means that you don't have any overhead from some interpreter. You don't have any of that. It just runs directly, which should give you a little bit of an advantage when it comes to speed. When it comes to raw execution power, because it doesn't have all of that overhead. That can be pretty nice. And that is why, Windows is written on C, just because it really needs that last little drop of performance. That's why C is there. Now, it's also a procedural language, which means that, well, it doesn't have any of this object-oriented stuff. Procedural language, it basically means, well, you just have these functions, and that's it. You just have these functions, and your your code starts from the top, goes down, it finds your main function, and in your main function, you just call some other functions. Of course, you can store some data somewhere. You don't need to store some data in a function. You can do that outside of the function, but fine. The actual code that is being run is just in some function, and that's about it. That's all that you do. While in C# or in Java, well, you have these classes and these interfaces, and just the whole way that you make things isn't really centered around functions. It's centered around these objects, these classes, these objects, object-oriented programming. And these objects have their own function, but then they're called methods, of course, and they also contain data, and then the methods act upon that data, and it's a bit different. You think about it in a different way than how you would in C. Does it really have any advantage? Some would say yeah, most would say no. And as always with programming stuff, it's always so divisive, these things. There are always angry programmers screaming, just typing furiously in Stack Overflow, no, you should be doing it the other way. My way is superior than yours. But in reality, if you have a language like C++ that does support object-oriented programming, just C++ has classes, right? It's not maybe as fully fledged object-oriented such as Java, but it has the stuff in it. And there's really no good reason why you wouldn't want to work in C++ instead of in C, because you basically, C++ also is a native language, so it also compiles some machine code, and C++ also is, well, semi-procedural, semi-object-oriented, it has a bit of both in it. So really in C++, you can do anything that you can do in C, but you can also just use some of the very convenient things, really, that C doesn't have access to, like classes and like constructors, and especially destructors are actually quite nice for just cleaning up your stuff. If you make a struct and your struct goes out of scope, well, it is kind of nice to just be able to like auto delete whatever is inside the struct. The structures are really great. You'll miss them when you don't have them. I'll tell you that. So really, why then not just C++? I mean, you can understand why not Java because of the speed, but why C++? Or why not C++? Well, again, there's really no super good reason for it. I personally would say that C++ feels a little bit cluttered sometimes. C++ has a very large number of features. It has a very large number of libraries, standard libraries. It's a very big language. There's a lot of stuff to learn and a lot of stuff to take into account, to think about. While C is just kind of simple, It has a couple of features, but really not that many, and you'll get familiar with them very, very quickly. And at that point, well, you can just program. You can just do whatever you want to do, and you don't have to look up constantly on the forums, like, hey, how do I do this? Because there are no magic functions somewhere hidden. in some random library. So maybe that is like a pro, but really not. So who is this really for then? Well, I suppose for people who will work with, or who have to work with like legacy code or with stuff like Windows or just old code that is already written in C and you have to maintain it and something like that, right? So you really don't have a choice. Or if you're just interested, if you're a scholar, like myself, of course, like yourself probably, watching right now. If you're just curious and you just kind of want to know, you want to learn some more programming languages, well, or you want to learn some history, honestly, good place to start is C. All right. With that out of the way, we can actually get this kind of talking about some more interesting stuff, some actual coding stuff. So how do we write and how do we compile C? Well, there's one little tiny unfortunate thing, and that is that Visual Studio right now, and we kind of found that out last week, because I really thought that that Visual Studio did, but Visual Studio doesn't actually support C, at least not at the moment. So you can write C++ in Visual Studio, and you can basically just pretend that you're writing C, that's fine. But actual C, like pure C, you can't do that in Visual Studio right now. So what then? Well, IDE-wise, I think you're kind of stuck with C-Line. And it's not that C-Line is such a bad IDE, it's actually a really good IDE. So I would recommend. Only C-Line, as far as I could tell, doesn't have a community edition. So you just kind of have to pay up. If you're a student, well, then it's free. If, you know, you're working on a job and you have a boss who is somewhat generous, you could ask. Maybe he'll get you C-Line. You know, so you don't always have to pay for it yourself, but if you're just on your own, you're not a student, anything like that, well, yeah, C-Line is kind of expensive. So there's that. If you are content with just using a code editor, then you could also do that. You could get Atom or Visual Studio Code. Visual Studio Code does support C, or at least you can get a C++ extension for either code editor or whatever code editor. You know, even if you program in Notepad++ or something, you'll have to get an extension. Maybe Notepad++ actually supports it out of the box. I don't know. I do know Notepad++ supports a few languages out of the box, but Notepad++ is also just not a very feature-rich code editor either. So I'd say that's kind of a downgrade from Visual Studio Code or Atom. So you probably want one of those two. And then you need a compiler, which will be MinGW for Windows or GCC for Linux. And there's probably one for macOS as well. I actually didn't look that up. Sorry. Well, easy enough to find, right? So you'll need one of those compilers. And then you'll need one of those code editors. And then you can get right started. Yeah, it's really as simple as that. Really as simple as that. Of course, you'd have to actually get some. You'd have to call the compiler from the console that you have in your code editor, but you should be okay doing that. It's all explained with the actual compiler there, so you'll figure it out. Yeah, not going into too much detail here. We have some other stuff to talk about, and this is not particularly interesting, right? Right, so then we actually get to Hello World, which is very interesting. Yes, I know. Hello World. Let's go over this this cool function here. Wow. Well, that looks pretty interesting. Well, actually, I can show you this bit of code in an even more interesting way, and that is right here. Can I even zoom in, actually? Oh, I think I forgot to enable that. So observe. I'll zoom in real well for you all. Observe. Hello World. If you run this, of course, and with C-Line, you don't have to do anything. Like with a compiler, what's that? You really don't have to care about that, because C-Line does all of that stuff for you. It comes with MinGW by default, I think. So, well, here you go. It compiled our thing, and then it has a Hello World printed out, which is, of course, right here. Let's go through this one by one, line by line. So we have this include statement here, which includes standard IO. Well, we could comment this out, and of course, comments just work like in C# or Java or anything like that. And you'll see that printf is no longer here, right? It's red now. So this basically works like a using or like an import. It's not quite the same. I have to warn you, it's not quite the same, but it's somewhat similar, right? So any functions that are defined in standard.io are now available to you right here. So we can go here. I think that is middle-click. Yeah, there we go. Well, you'll find that, well, you get a whole bunch of stuff here. We'll get a const jar format. With them some variable arguments, that's what that's called. And then you have, well, a whole bunch of stuff here. Well, whatever. We're not here to understand any of this. But it is now included in main, and you can just call it, which is great. What is main then? Well, main is, of course, your entry function. Again, just like C# or Java, I'll be drawing a lot of connections here with those languages. Because, well, I'm personally most familiar with C#. So, main, well, just your entry function, that's it. You can also accept like arguments, you know. So I think it's usually called argn, it's like int argn, and then you have, I think it's char pointer, which will be argv. I think that's how they usually do it. Let's see if this runs. Yeah, that runs. So there you go. So this, you can get all of your strings in, you know, from the command line, which is also nice, but we don't really need that right now. Inside of main, well, you'll notice actually that main returns an integer. It's not a void. And we can try to do it void, and then we can get rid of this. Return type of main is not int, you know? It doesn't really like that. And if I run it, well, it does work, but I do think I get a warning. At the very least, if I scroll over here, I get a return type of main is not int. So it doesn't really like that. You should probably use int. Why? Well, because C really doesn't have any error handling. Like any exceptions or something like that, it doesn't have that. It does have some error handling, but it doesn't have any formal exceptions. So you can't really go like, oh, something failed. Well, now throw a new exception. Of course, a new isn't even a thing in C. So yeah, you can get a function throw from some weird header file, but it isn't supported by the core language. So, well, what do you do then? Well, if something goes wrong, you just return 1 or some error code that you might have. If you return 0, that means that your program exited successfully. Any other value is an error, or is considered an error. So that means that, well, you can make your own little error messages, which are then paired with a unique integer, and then you can just return this unique integer. This is my error code. Something went wrong. Please look into it, you know? So that's kind of nice, and it's very different from other languages. Let's get into the bread and butter of everything here, which is, of course, the printf. So what are we doing here? Well, just a normal print doesn't work. You have to do printf. It's fine. Print line doesn't exist. Println doesn't exist. You can't print a line. So if you printf, well, there is no line termination here, so you probably want to have \n in there as well, actually, now that I think about it. And this means that you actually get this extra line here. You actually terminated your line, so if you do another printf, well, your hello world 2 will now actually be on another line and not on the same line. So you have to see, so you have to kind of think about that one. On Windows, it's \n. I believe on Linux, it can be like another sign as well. I'm not entirely sure, actually. I never program in Linux, guys. Don't ask me anything about Linux. But yeah, on Windows, it's \n for line termination. If I don't use any line termination, then you'll see that it is all in one line, which is probably not what you want. So think about that when you program. Also, this is a formatted string. Well, how do we actually format the string then? You could imagine, right? Maybe you want a little function here that says like, well, I have 7 apples, but no, next time I have actually 4 apples. So I should do int apples equals 4. That's 5. That's a 3. That's a 4. It's 34. That's yeah, great. Well, now I won't have 4 in here, of course. Well, how do you do that? Maybe we can do something like +7 and then plus like apples. Can we do that? No, we can't do that. Yeah. This stuff doesn't work in C. You can't just append strings like this. Oh, now we're doing some crazy stuff. Ah, Oh, but now it is 4. So can I do apples in here? I don't even know what these... Oh, right. So now I have like fake... So these are like fake-o, you call these apostrophes? Yeah, so this will just print apples. I don't know why C-line just does that by default. Yeah, so then it will actually print the apostrophes, which of course we don't really want. You can't just add plus apples like that. Doesn't work. So how else do we do it? Well, here we go. So I can do how I have percent, and this one confused me for a time, D apples. And D here, oh, backslash N, almost forgot. I'll put a period in there as well. And the percent D actually references, well, this first value that you put right next to the printf, which will be apples, as an integer. So this will now, apples will now be read as an integer and put in there. So if we do this, we get, I have 4 apples. You know, and I can change it to 5, doesn't matter. I can run it again and I'll get, I have 5 apples. Why is it D? I actually don't know. We can also do a %f, which will read in a floating point value. And when we do that, I have 0.0000 apples. Why? Well, this integer is 5. So we have a line of memory, you know, 4 bytes, 32 bits, where we just have 5. So a couple of 1s all the way at the beginning. And the rest is all 0. That represents a 5 in an integer format. If we now read this integer as a float, we get some issues. You know, a float with all zeros and then maybe a couple of 1s just gives us 0, basically. If I make some really large int, I'm sure I'm going to get a very weird float. I still get a 0 float. Maybe it just really doesn't like... Maybe it just really doesn't like integers in here. It just doesn't do anything. Even better. It's just 0, guys. It's just 0. So you have to kind of pay attention to your types here. I can also do U for unsigned. It's a very weird looking U. And that will work. That will work. Still, if I have -5 in here though, it's a bit weird for apples, but it doesn't really like that. You know, you get some overflow stuff. So you get basically UN.max value -5, which is a really big number of apples. We can also go for, not D, but for S, which is for string. Of course, if we put apples and int as a string, it really doesn't do anything. Yeah, we even get a process finished with exit code minus this, which isn't 0, which means that we actually had an error. So we can look up this error code and we'll probably find that the printf really couldn't interpret this apples as a string. Kind of sad. We also have C for chars. That might work actually. -5 read as a char. Yeah. So -5 gives us a 1 char, or a power of 1 char. Yeah, that's beautiful. That's beautiful. I think 32 is like space in general. Yeah, then you'll get a space. I actually don't know. I think like the 50s or something, you get normal letters. I have 2 apples. You know, black magic. I don't know the whole Unicode character table from the top of my head, but apparently Unicode character 50 is a 2. Well, there you go. 2 apples now. You know, it works. If you ship this stuff, like, it will work and no one will see that you did anything wrong until someone tries to kind of maintain this code and they'll just be thoroughly confused. That's actually kind of funny. Anyway, code abuse. I love it. Even ASCII. Oh, yes. Sorry. ASCII. Yes. Ugh. Still. That is a heck of a fun time trying to maintain this code. All right, well, after we have this, or after we use 1 character in here, well, why not use 2? Why can't I just put in another integer? I mean, why not, right? So we'll just do pairs, and bananas. There we go. So this many apples, I have this many pears, and this many bananas. Can't actually read the rest of the string, but that's okay. We'll just put this here in front. So we have apples, pears, and bananas. Should probably change this one to a D then as well. And this will also just work. We can just, you know, we can have 3 specifiers for a for a special value in this string. You have 3 of them, and then as long as we provide these 3 values, we're totally fine. Of course, they are in order, so apples will appear first, pears will appear second, bananas will appear third, as one would expect. And of course, if this is a string, then pears should probably also be a string, which can be like 20. And there we go. So now we'll have 50 apples, 20 pears, and 50 bananas. Exactly as we would expect. Now, there are some other ways, some other prints as well. We also have an printf, which will print to a string. So as you can see here, if we, can you give me the function signature? I guess not. So it needs a stream and then the format thing. So at first, we might need to make a little bit of a buffer to put everything in. I'll just very quickly write something up. So like a char, this will be the buffer array of 256. There we go. We'll talk about characters and strings in a little bit. We can put buffer in here. And then we can just put in the same string. I have 20, or I have %t apples with apples in here. I know, \n and all of that. And if I then later printf, there we go, my buffer, we should see the same thing. I can uncomment this. I know I'm zoomed in like crazy right now. Let's zoom out just a little bit. I have 50 apples. There you go. So this also works. Basically, this printf takes in a string and then prints a formatted string onto it. Printf just takes in the default, which is just your output, your console. And it prints the formatted string. We also have a file, printf. You know, that's the same thing. That's the same thing. I just need to open a file and then I can print some formatted string to the file. All works in exactly the same way. Yeah, I think we covered basically what main and printf do. So let's kind of go back to what we had right here. And then we can go back to our presentation. There we go. Now that we know how Hello World works, we can really get into the programming stuff, right? We can actually start programming. And that's great. I love programming. But there are a couple of things that you might want to think about when programming in C. And one of those things is pointers. And you might have heard of those. And they really do have a reputation of being like very difficult to work with and very confusing and memory leaks, you know, all bad stuff. You know, C# calls it unsafe code. It's very unsafe, guys. Don't you dare use it. You even have to enable unsafe code in your C# project. If you even want to use it, you have to do that. Otherwise, it just doesn't work. So what's up with these pointers? Why are they so dangerous, and how can you use them to your advantage? Because pointers really are what makes C such a powerful language, to be completely honest. Well, what it does is a pointer is actually very simple in its essence. So you have some variable A. Look at the graph. And also, yes, I did steal this from Wikipedia. So you have some variable A. You just store it somewhere in memory. You know, storage address 0002, whatever. Doesn't really matter. And the contents of this variable is 0 or 1008, which is a memory address. And a pointer type, let's say an int pointer, always contains a pointer, you know, a memory address that points to some other memory address that contains an int, such as a char pointer also stores some memory address that stores a character. And same with a double. A double pointer contains a memory address that actually contains the double. So you have like this little in-between step here. So instead of a normal double just storing the double directly right there, it actually stores the double in another location, somewhere else in memory. We don't really know where, but the double pointer contains that memory address. So you can read this memory address. You can see, oh, this memory address is 1008. Well, let's go to 1008 and let's read that value to actually get our double back. If you put it that way, it's not that useful, right? If you just have one normal double, let's say 0.05, and you want to store it somewhere, you aren't going to store that somewhere, you know, very distant in memory. You aren't going to create a pointer to that, because you have to do like 2 memory reads and you have to go all over the memory to just find your double. That's not very useful. When is it useful? Well, I do believe we are going to get to arrays in just a second, but there are also some other useful things. So first of all, oh yeah, right. Can I go back? Boop, 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 boop. Go back. Yeah. So when is it useful? Well, pointers, for example, are useful when you use functions. And I'll show that right now. And then we will get to some other use cases in just a second, just like arrays. I thought that was the next slide. It's the slide next to that. I'm sorry. So let's say we have some void function. And let's say it does, it's just add, you know. And it just has like an int value. It does an int, you know, maybe a bad example, I don't know. Let's just have an int value and an int addition, right? Addition. There we go. That's a function. Now what we want to do is we want to just say, well, value equals value plus addition. And you can find some real use cases for this, you know, this is just an example. Well, this is fine, but now if I call this, and I can do that, right? So I can have apple, which is 50, and then I can have like extra apples, which is like 20. So it ends that the total apples equals, no, not like that. Then I can say, well, I can add, and then our value is apples, and I can add to that the extra apples. There we go. Then I can print apples. I have that many apples. There we go. Put apples in there. Okay, now how many apples do I have? 3 guesses. 3 guesses, boys. 50, 70, well, it's 50. It's 50. It's as if this add didn't really do anything. And that is because, well, if you just take in like a normal integer here in your add function, well, it just copies this value of apples over here, and it just copies the extra value over here. It doesn't take in the original, it just copies it to a new variable. Value here. Which means that if you now write to value, well, it's just some other integer. So when the function here ends, well, that other integer kind of gets lost, right? We'll talk about stack and heap in some other lecture. Just gonna get lost. And apples, well, it didn't do anything to apples. So what you might want to do is make this an int pointer. And if we have an int pointer here, well, this just points to some other memory address. So now what we can do is we can say, well, value, we can actually, and this is actually very important, we can read in what is at value, right? And then we can set that to whatever is at value. You know, the integer that is actually at the address of value. And you use this star at the left side to dereference. Just got here legendized welcome. What that is. A couple of things. Can't do the lecture twice though, but you are free to join. We are talking about pointers right now. And then you can just add addition. We don't really need to store anything at addition, so we don't care. We can just make a copy, whatever. And now when we print this, well, this... Oh. Very important. I forgot to change the calling function. So of course, if we put in apples, that's just some integers. That's not an address. So we will need to take the address of apples and pass that here to our add function. And that will then give us 70 apples. Wait, are pointers like the ref keyword in C#, or is it something entirely different? That's actually a great question, Legendized. It is different. Just like how references and pointers are also different in C++. So they're not quite the same. That's because a reference isn't really an address. right? What you can do with this value pointer, for example, so I can just say, well, this is an address, right? It's just some number that points to a specific memory location. So I can just add 5 to it. You know, you see that this compiles, and I can even run this. 50 apples now. You know, that totally works. Oh, wait. Well, I'm storing our value here. So what I might want to do to get some real crazy results is to read in whatever is an address value, but then like 5 spaces further along in memory, you know, like all the way back there. We don't know what that is. We dereference it, so we get the value that's at that address, and then we add that to value. So what we're going to get now is 32,779 apples. It's like magic. You can't do this with a ref. You can't just take a memory address and just hop along a few places and go to a completely different memory address ref. So in that aspect, they are very different. Of course, if you just use them in a safe way and you don't do anything stupid, like kids actually never do this. Please don't ever do this, because this is completely unsafe. You might read something that is just that's protected memory or something like that, right? You do not have ownership of this memory address at value +5. So don't change it. Definitely don't change it. Probably don't read it either. So pointers are like addresses for different bytes in the RAM. Yes, they are exactly that. Now, incrementing your pointer can be useful when you are working with arrays. We will get to that in just a second. So working with arrays, doing like some memory address and then going along like +7 or something, that is actually exactly how you are supposed to work with arrays. So that is nice. That is the nice part about pointers. But if you want to do something like this, just don't increment, please. If you use them like this, yeah, they're basically like references, yeah. Remember the syntax though. So an int pointer value, that is just the memory address of an integer. I can of course make this some char or some unsigned short, for example. You know, you can put any data type in here. Even if we make like a struct, you can put that in there. Now, so let's change it back to an integer. Then we can read whatever is at the pointer by dereferencing it with a star to the left of the value. And if we just have some variable, we can get the address of that variable with the ampersand to the left. Right? So the ampersand and the star kind of do the opposite thing in this case. All right, well, let's run it one more time. We should see 70 again. Yeah, we do. Okay, perfect. Basically how pointers work. So the dangerous part here is, of course, kind of what we just did, and that is just incrementing your pointer without actually knowing what you're going to increment to. Like if you do not have ownership of a certain address, you shouldn't read it and you shouldn't write to it. You definitely shouldn't write to it. If you read it, you can get away with it, but you probably shouldn't. If you write to an address that isn't yours, you can get into some serious trouble. So don't do that, boys and girls. Don't do that. There are some other dangers though, and that is we're gonna get to now. Well, let's just say that we actually want to get a bigger bit of memory, right? So it's really more array-ish stuff. So you know what? I'm gonna skip to arrays. I'm gonna do arrays first, and then I'll get back to the other half of pointers. I think it might be smart actually. So arrays. Arrays are also a bit different than how they work in C# or like in Java. In C# and Java, they are classes, they're objects. So they're not just normal value types, there are reference types in those languages. And basically they encompass the functionality that the C array gives you. So you are never really exposed to what a raw C array does in C#, but you have like a container around it that does some nice stuff for you. So for example, in C, an array doesn't contain like a length or anything like that. You don't have that. If you make an array of, let's say, length 10, just like we do here in the top line, first of all, you don't define it as an int array R, you define it as an int R array. Important distinction there. Also, you have to define directly how much or how many values or how much memory you want to reserve for it. So we just have to hard-coded in 10. There's no other way around it. You can use macros or something like that, but we'll get into those later. But still, that's still hard-coded in. You know, at compile time, it needs to be constant. In C, or I mean in C#, you don't have to do that. You can have dynamic arrays all the way. So you can just, in C#, you can, for example, say, well, make my array R of the length k, and this variable k has been given to us from some other function. So it can be whatever, you know, we can even randomly generate one. You can't do that in C. Compile time constant. So you can define it as in the top line. You can also define a new array as in the second line. So you can also define an array with just an array initializer, as it is called. You have just 10 zeros if you count that out. And that just means that it will create an as small as possible array to put all of these zeros in. So that will just be an array of 10 integers with these 10 integers, these 10 zeros in it. The top and the second line should create exactly the same code, 0 initialized, which is pretty nice. Now, maybe you don't really want to hardcode anything. Maybe you want to create an array of a random number of integers. Well, in that case, you can't use these top two array initializers. You'd have to call calloc. So you can get an int pointer array equals calloc 10.4. And what this means is it's a function that we kind of introduced in the previous slide, but I skipped the previous slide, so I'm gonna have to do that here. calloc basically creates a bit of memory for you on the heap, not on the stack. We'll get to the difference of the two in some other lecture. But it will create some bit of memory all the way out there on the heap that contains 10 4-bit values, 4-byte values. That's what the 10 and 4 mean. So 10 4-byte values. And an integer is a 4-byte value, so it will create 10 integer values for you. Now, it doesn't really know about what you're going to store in there. It doesn't really know about integers. So, you know, it can't really do anything with that. You'd have to specify exactly what size your value type is there, or what size your type is there. And it can't really initialize anything to some crazy value, but it will initialize everything to 0. So it will just take all of the bits that you just allocated and put them all to 0. That's it. In some other languages, well, you might be able to create an array and just say, well, set everything to like 5 or something. You can't really do that here. Can't really do that here. So I can totally alloc just 40 bytes and store 10 ints in there. Yeah, absolutely. Now, is then an int pointer, because we just saw here from calloc you get a pointer back. So is an int pointer then the same as an int array? Well, it kind of is and it kind of isn't. So let me show you. So I suppose we will get, let's say we will do here a const. I think I should best do like a char array, right? Well, we'll get the strings in a little bit. We'll just do an int array or an int r array. And in here, we'll just store 10 integers, whatever. We'll also then create an int pointer, array 2, which will be calloc, and we'd have to import or include, #include the stdlib.h. For that, there we go. And we'll have to do 10 and then size of int. And size of just returns the number of bytes that is contained by that type. So for int, that returns 4. That is constant, of course, but still. Man, C++, it's 15 years that I learned it. I don't remember much. Yeah, in C++ you don't use calloc. You really don't. And malloc you also don't really use in C++. Calloc and malloc. malloc, calloc, whatever. So that's probably why you don't remember it. In C you just call, or C++ you just call new. But that is something that doesn't exist here. So yeah, you don't call new, you call calloc. Now, what can I do with these? Well, in both cases, I'll actually initialize both to something, you know. Do I equals 0, I smaller than 10, plus I. then I can say, well, for R at index I, I'll just set that to I. And for R2 at index I, I'll just set that to I. And then what I can do after that is I can do another for loop. Just basically the same thing. And now what I can say is, well, I can just printf. Then I can say iteration d of just R is, and then that is another integer. Will be, of course, I, and then of Ri. These two should always be the same, of course. And then the same thing for the other array. So we're just going to print them both out. Iteration d of R2. It's the same thing, but with R2. There we go. Yes, that is a Star Wars reference for if you were wondering. So if we just run this, well, are we going to get the exact same thing? Well, yes. 0 of R is 0. 1 of that, okay. Yeah, good, good, good. Only they're not. Only they're not. And I want you guys to look at this. Look at this piece of code. And what exactly is wrong with this code? Because there is actually a massive error here. Oh, Pandas, thank you so much for the follow. And welcome. Can someone from chat tell me what the error is here? And it is not just any error, it's actually a pretty significant error that doesn't really get picked up that easily. Oh, wait. I'll get mixed up all those languages. Sometimes I don't understand why my JavaScript don't know what an int is. Nah, it happens, man. It happens. Right, anyone? All right, I'll give a hint. Something memory leaky. Very leaky memory. All right, a memory leak then. But where? Ah, that's a shame. Well, I guess I'll have to spoil it for you. Right here. R, no memory leak. No problem. R2, big memory leak. Big problem. So if we call callalloc, it allocates a bit of memory on the heap, somewhere off in the distance, while R, well, that just generates a little bit of memory on the stack. Once we get here to the end of main, the stack gets destroyed. And so R, which was declared on the stack, is gone. It's poof. Gone. However, R2 is off there somewhere on the heap, and that is very far away, and, well, that isn't destroyed. So actually, this whole array, after we finish main, this whole array still exists in memory. If this wasn't the main function and we didn't just quit the program here, if we had like an actual application loop, you know, like a window loop, and you just generate one of these every single iteration, you get to notice that your memory usage is very slowly but surely going up, and it isn't going down anymore. Well, that's because of this. You keep generating a new array of 10 integers on the heap over and over without deleting them. So at the end here, you kind of you have to call free on R2, and you'll have a sneak peek of how free works. So free does basically the opposite of callalloc, in that it just frees the memory up again. So after this, the memory, the pointer, is released, and you're done. You're good. No more memory leaks. You still get the same result, of course, but you won't be noticing a steady incline in your memory usage in your program, which is kind of nice. Doesn't the operating system clear that memory after the program is closed? Yes. Yes, it does. So in here, I suppose it's not as big of a problem, but do remember that if you basically teach yourself to do this without calling free, you're gonna do it in some places where it isn't as innocent, you know? Like in a game loop, like in some sort of mathematical application where it's really, you know, millions of iterations just to go through one matrix, and then if you allocate memory like this, like a million times, you're gonna run into some memory issues. Yeah, gonna run into some memory issues. So you should teach yourself how to do this properly. And this really, all of the commotion around pointers stems from this bit right here. Well, especially the free part. Can I? No, I can select both, but especially the free part. Just using pointers like we did before, with just taking the memory address, you know, just take the memory address of I. We can even print this. I'll get some weird values in here, yeah. Memory addresses. That is no issue. It's no issue. It's fine. But once you do this, and you forget the free, well, then you get into trouble. And even if you call calloc and you delete it in the same function, it's still quite easy to see, right? But what if we just have like a void and then generate array for us, and we just kind of get like an in pointer back actually. And what it does is it just does this for us. Maybe it even just fills R2 for us. That's a handy function. So it just creates R2, it fills R2 with values, and then it returns R2. You know, and all that we have to do is we just have to do int pointer R2 equals generate array. There we go. Well, there you go. We don't see this. You know, we don't see the top function. That's in some other file somewhere. Now we just have this. Int pointer R2 is generate array. Okay, great. Well, let's just use that. And yeah, we're fine, right? Well, no. No, you're not fine. You're not fine. This is a memory leak. You know? That's a memory leak. Hello, I will not follow lecture because I am small brain. That's okay. That's okay, Jimmy. Thanks for dropping by, though. So, you know, that's a bit of a thing, a bit of an issue. So what you would rather do here is just never really make a function like this. Also notice that the standard C functions never do anything like this. Well, except for calloc, of course, but there's no way around it. You know, calloc itself has to do it. There's no way around. In general, in just standard C functions, you'll actually see something like this: int pointer and then R2. And what you'll see then is that we have to allocate or create the memory around R2 ourselves, and then we can call generate array with R2 in it. There we go. And then we don't return. And then this will just fill the array. It's not really generate anymore, it's more like fail. Okay, man, I have to leave for now. I'm sorry. No problem, debunked. Thank you for dropping by. And also, Jimmy, I am writing Minecraft in Legacy OpenCL. Oh, my Raspberry Pi. You're a Raspberry Pi. That's very interesting. Do let me know how that goes. Right, but now you see that we can, again, create our memory in the same function that we use it, and then that means that we can free it at the end, and then we will not forget. If you generate some memory in a function, then and you pass that memory to someone else, it's a little bit dangerous, because you don't really know if that's someone else, even if that's you, is going to remember that it has to generate, or if it has to manage this memory now. It can be a little bit confusing. And you can maybe forget. And if this generate array is then in some weird library somewhere, you know, which you never access ever, yeah, you'll kind of get a memory leak, and then you'll never be able to find it. Good luck. Good luck with that. Yeah, it can be very difficult. So please, please, please try to keep your callocs and your frees close together. Any other differences? Well, yeah, this is again stack and pointer, right? So actually, if you were to generate an array int r here, and you were to return the array like this as a normal array initializer, then you'd find that whatever you return, well, it doesn't actually really work. Because, well, at the end of this function, this array gets deallocated, right? It's on the stack, so it gets deallocated when it reaches the end of this function. And so the memory that you return, this pointer, is completely invalid. Like, it doesn't exist anymore. It's basically like you called free on R2 here. Basically like you call free and then you return R2. You know, that doesn't make any sense. You can return a bit of memory and then or you can free a bit of memory and then return it. Well, you can, but you'll definitely run into issues then. So that is basically the main difference between the pointer and the array for arrays. Right. Now that I think we have covered that, yeah, we've done this. So let's actually go back one to pointers. So we have now already seen calloc, which says number and a size, calloc. And we have also seen free, which takes in a pointer and frees a bit of memory. It's very important. That's why I put all of those exclamation points in there. We basically did the demonstration now. I suppose you should know about malloc as well. Here we go. We can also create an array with malloc. But malloc is a little bit different than calloc. So what it takes is just one parameter, just one size. What it needs you to do is just 10 times the size. This is just the number of bytes that you want to allocate. So for 10 integers, so that's just 10 times the size of an integer, right? 10 times 4 or 40 bytes. This will also work, and it will also return a pointer as R2, array 2. We can then maybe not generate it here, R2, and then we can print this and see what this looks like. Looks like, here we go. It's actually of course, it's giving us the same bit of memory that we had before, I'm sure. Oh, that is funny. Okay, let's generate a bit of a bigger array, and then maybe we can generate it like this. No, of course not, because I'm not going through 20 values. There we go. Oh, and I'm overriding everything here, right. Get rid of that, okay. So now we have two arrays. So both are not zero initialized. I'm sorry, I did say that before, that this was zero initialized. That is not the case. I'm very sorry. You have to something like that or something. Does it only do the first value? No, that sets a whole array. Okay. Yeah, so this is how you zero initialize an array. Anyway, you can see that now array 2 is just full of garbage. It's just random variables. This malloc doesn't set everything to 0, well, calloc does, actually. So if I use calloc again, and then I print this, well, look, everything is 0. So calloc allocates a bit of memory, you know. 20 times 4 is 80 bytes of memory, and then it sets every single bit to 0. Malloc doesn't do that. It just allocates 40 bytes and it's done. So you can still use this for arrays if you are sure that you are just going to call something like generate, you know, and that will actually work on 20 values. There we go. And then it works fine, you know, you don't have to set everything to 0. But, you know, you kind of want to keep that in mind, right? Sometimes you do really want everything to be 0 initialized, and then calling calloc is just very handy. It's just very nice. So just do that. Otherwise, malloc is just fine. There's no real other difference than that. And we've already talked about the most important thing here, which is free. I can't say that enough. Please do not forget your frees. And then we have gotten to strings. Strings, just like arrays, are different from how they work in other languages. String is just a character array. It is really just nothing more than a character array. And it is, yeah, a little bit uncanny maybe. How a string is really just a character array. And it's just a fancy way of storing characters. So if I were to call the top line here, const or not const, doesn't really matter. Char pointer string is just some array of characters. That's why it's also a char pointer, because it's just some array really that you are assigning. And it's, well, that's just the default, what do you call it, the string literal. You can put that in there and it will just construct a little array for you of characters that represent hello world, and it will put that in that pointer. Great, awesome, nice. Well, first of all, because this is like a const char pointer, or it's just a char pointer, you can't really concatenate strings in C, or at least not in the way that you do it in other languages. So you can't do like a string and then plus some other string, because Well, both strings are basically just pointers to a bit of memory with a couple chars in there. If you add them together, well, that's a bit weird, right? You'd have to kind of create a new bit of memory somewhere that is big enough to store both, and then you just have to copy and paste them over. So it's not as simple as just adding them, as I'm just reading both at once now. That doesn't really work. You'd have to create a new array and then just copy everything over, and that's a lot of work. So you'd have to do that very explicitly. The second line is basically the same then as the first line. So we can just create a char array, just with the array constructor. And then we can just put in the whole hello world thing. And that will also create hello world. Only this one is a bit different than the first one. There is really only one difference. And you might have heard about something called null termination. And the thing is that in a string literal, like in the top line, null termination is done for you. So really what the top line says is hello world, and then it has like a 0 after that. It just puts a little 0 after that. In the second line, well, you very explicitly tell it not to put a 0 after it. Right? You just put all of the values in there yourself. So clearly you didn't want a 0 in there. Now what happens if I do the first line? Or what happens if I do the second line? In here. So what happens? I just make some char str array. Let's just set it to, oh, this is gonna take a little while, boys. And set it to hello. I'll not do the whole hello world thing. That's gonna be a bit crazy. Just the hello. And then I'll just, I don't have to free anything here. All right, this is just a normal array constructor. So on the stack, so this thing will just get cleaned up. No problem. Printf, well, then we can just put a %s in here. Just do a %s, and then we can put the str here. Also, maybe we should do a line termination. There we go. Now, if we run this, we get this. We get hello 0.3. That's interesting. Let's run this again. Hello, one of those weird signs, a 1, a blank space, a 3, and a comma. Cool, cool, cool. Then we get hello with a square, a triangle, upside down triangle, 2 exclamation points, and an R. Weird. Well, the thing is, if we create a bit of memory like this, it really only contains an H, an E, an L, another L, and an O. Once printf reads through that bit of memory, it will just go, well, H, great, E, L, L, O, fine. And then it just reads the next one, because, you know, it doesn't really know where to stop. You didn't specify a size of the string. Some array, just like I said, an array doesn't actually contain the size of itself in C. Strings definitely don't do that, because strings really don't exist. It's just a star array. So it doesn't really know where to stop, so it just kind of continues, and it just reads, oh, well, in the next bit of memory, which you do not own, by the way, you never allocated that. In the next bit of memory, well, there's some value that once read in as a char, you know, 8 bytes, evaluates to, well, whatever that thing is. And then after that, it's a square, and after that, it's an upside down triangle. 2 exclamation points, then an R, and then all of a sudden, it finds a 0 somewhere in memory. And usually there are quite a bit of zeros in memory, so you'll find that these unsafe strings, these bit of chaos strings, do terminate relatively quickly. It's of course not good practice though, so you probably didn't want these triangles in your string. But it will find a 0, and then it will say, oh, there is a 0 here. That means that I need to stop. I need to stop reading, and I need to stop writing, you know, we're done. If we want to prevent this, we'd have to null terminate our own string. So we'd have to put in, well, not a 0 character, actually just an actual 0 here in our array. And then it will read that 0 at the end of hello, and it will stop. So we'll just get hello. Awesome. You can also see that if I hover here, it doesn't produce like an extra space or anything. It's just hello, and then it just stops. It doesn't print the 0, of course. If you want to be very explicit about null termination, you can also just put a null here. This is a macro. We'll talk about that a little bit later as well. But macros, in this case, it just evaluates to a 0. So there you go. And that will do exactly the same thing. If we were to create a char pointer str2, which equals hello, hello, if I can write, and we'll print str2, we'll see that this never happens. You know, we'll always just get hello. We don't have to explicitly null terminate our literal. I mean, it already does that for us. It already interprets this as this. It's the same thing to see. That's good. That's nice. That's nice. Anything else that you want to say about strings? Well, of course, because it's just a pointer, and this one is not const, we can just say, well, our str at 2, we'll just set that to x, you know, whatever. Print string. You can do that. And you can hack slow. You know, you can totally do that. Not entirely sure why you would want to do that, but you could. Same thing about if we just create a 256 sized string here and we do something like s print f. We already seen this before, but we just create some string like hello, and we just put that inside of this string. Then we just kind of print that. Then we also get hello. So this string array, of course, is initialized as, well, not 0, but we can actually 0 initialize it as well. Yeah, there's no problem. We can do that. And then once we give it to printf, well, printf basically going to copy, or sprintf, going to copy this hello into the first elements of str, our string. So the first will be h, then e, l, l, o, and then, of course, well, even if we didn't null terminate or null initialize this string, then still at the end it would just put a 0 there, just to indicate that here we're done. And then in printf you can just read that, that's totally fine. Now if I put too few characters in here, if my string only contains a space for 2 characters and I put 5, like with hello, in there, you might see some interesting stuff. That actually worked, that is crazy. That actually works, it's crazy. Yeah, well, in any case... Oh, I know what's happening here. Yeah, you can do this, this will work. But it is very, very unsafe. Because now there are 4... Remember that there is an implicit 0 here at the end. Now there are 4 characters that you have not assigned, or that you have not created yourself. And you're just putting values there. So you have 2 characters that are in your ownership. You own those characters. You can do whatever with them, whatever you want with them. But the other 4 at the end, for the L, L, O, and the 0, well, they are owned by the operating system and maybe even owned by another application. So if you have some other application open, and actually me doing this is already quite dangerous, to be completely honest. I probably shouldn't do this, even on stream. Because those other bytes, those might be owned by OBS Streamlabs, for example, or by Google Chrome, or by Visual Studio, or by Discord. And you just change them, you just forcibly change them, you just put those L, L, O, and 0 in there. You don't care whatever was written there. So now, the data that was owned by Discord or even by Windows, and then you're in real trouble, is now corrupted. It's just corrupted. There's just some garbage data in there that you just put in there. You don't know what you're doing. So, yeah, you can run into some issues with that. Like, you can make other programs on your computer crash. You can make Windows crash. And that's a bit of the dangerous part. So, if you know that this string is 5 letters, right? But then also 1, 0. You should definitely assign at least 6 characters here. And then you're safe. Then you're safe, right? But make sure that you always assign more space than you actually need. Or at least as much as you will ever need. Because maybe sometime someone wants to write hello world, and then 6 is all of a sudden way too little. So having 256 as like a base for like a single line is usually enough, right? There are very few lines that are longer than this, but it is important to keep that in mind, because there are cases where 256 will not be enough. And then maybe just dynamically assigning a string, you know, with calloc, which is still possible, right? So you can still do a char pointer C, or char pointer string equals calloc, and then I want just 256 chars, which are 1 in size. You know, size of char. I just do size of char. That's totally a thing that you can do. And this will also work, just don't forget to call free. You know, that is something that you have to think about. Don't forget to call free. Da-da-da, and hello world. That works also fine. But then in here you can put in like a dynamic variable, right? So size of whatever hello world will be, so we can make that a bit shorter or a bit longer. Right, so I think that about covered it. Yeah, so review. So in the end, is C better than C# or C++ or Java or Python? Short answer, no, it isn't. Long answer, well, it depends. For me to say that it's better, it's a little bit... It's so dependent on your situation, right? In most cases, you will not need the performance given by C. You will not need that absolute super fine level of control. You usually just don't need it. And in that case, using C# is just very convenient. Using Python is very convenient. You can write a bit of code in Python so quickly, while in C, it can take you so much longer. And in C, you then have to think about, oh, well, did I free all of my memory? Is this stack or heap allocated? You know, is this function returning me a safe pointer? Or what is the size of the string that I'm writing to? Is it big enough? You know, you have to think about all of these memory management things, which gives you so much control. It gives you absolute control, which can be so just insanely amazing for optimizing your program. But you can make mistakes very easily, right? And with Python, Python just kind of fixes that all for you. Like even during runtime, Python kind of fixes things as it goes. And it is able to save your program sometimes, Python, but sometimes not, of course. But C, well, not really. Well, C will just continue. Like C will, you know, just read outside of memory. It will corrupt your windows if you're not careful. It doesn't care. It doesn't care. It just does whatever it tells you to do. And if you say something stupid, it will do something stupid. So it's a lot of thinking. And it's not very convenient. But it is super fast. So basically, if you really need that super fine level of detail, that super fine level of control, and that super amazing speed, then use C. Otherwise, please just use C# or even C++. It's C++ even is a little bit better. It has some containers for your pointers, you know, unique pointers and stuff, where it can be a little bit more safe to work with. Also, things like lists and stuff, you know, in the vector class has already been done for you, so it's a little bit quicker to work with. It's a little bit nicer in that regard. Java and Python, of course, no need to say this. Python is just super easy to work with. Right, that's kind of it. So are there any questions? This has been it. Thank you all so much for watching. If you enjoyed this video, then please do hit that subscribe button and do leave a like. It helps me out so much, guys. It really does. Algorithm and all of that. And if you want some help, if you need some more help, or if you just want to share some of your C projects, then please head over to the Discord server. Legend Dice just came back. This is so sad. Yeah, it happens, dude. It happens. Head over to the Discord server. Link is also in the description, of course, and also in the chat right now. And we have such a nice community. Really, we really do. Everyone is willing to help you out there. And we love to see each other's code as well. Yeah, be happy to look at it. Anyway, that was it. And yeah, have a good night, everyone. Bye-bye.